Troubleshooting network address translation. At the heart of NAT is the word translation. That's really all NAT does, is take one IP address and translate it over to another. Typically it's done with the RFC 1918 private IP addresses as they translate over to the public internet addresses, but it can be between anything you want. The goal of NAT is twofold. One, it adds security, because if you are using private addresses in your network back here, then nobody's getting to them without passing through that translation device where you can put some increased security. The second reason is to overcome the shortage in IPv4 addresses out on the internet. You can now take one IP address and share it between hundreds, if not thousands, of internal hosts, allowing us to sustain, essentially on life support, the IP version 4 public addressing scheme. Now you can do one-to-one static NAT translation where I go in and say I want to translate 192.168.1.50 to 200.1.1.1, which could be the IP address assigned to this interface, or maybe you've got a whole /24 that's been allocated to you. If that's the case, what the service writer does is put a route in their router saying to reach, we'll just say 200.1.1.0, go to that guy right there. And they set up a route in their system. Then you can start putting NAT entries, static NAT entries, on your router for any of those addresses, saying 200.1.1.10, for instance, would be hit from the internet and pass into this guy right here, or vice versa. This one always goes out and becomes 200.1.1.10. Now what you're seeing right here on the screen is called PAT, or what Cisco calls NAT overload. This is what allows you to share that one IP address. Anytime you have a computer and open an application, let's just say Firefox, and go to a website, Windows will dynamically assign a port number that's unique on that computer to the Firefox application. That's how it knows when it's receiving all this stuff from Pandora and stock tickers and the waste of time Windows bar on the right hand side, or whatever other applications you have running. It knows which data goes to which because it assigns a port number to each one, and all the incoming data to your computer will have as its destination one of those port numbers the computer is assigned. So let's just say when you open up Firefox, it dynamically assigns 6711 to that application, right? When you go out to the internet, let's say to access Cisco.com website, the router with NAT enabled, and NAT overload specifically, will tack on that source port number 6711 to the outside address 6711. So when Cisco.com gets it, it sees it coming from this, there's a key word for this, socket. Right? And when it replies, it will reply back to that socket, at which point the router looks at its table and says, oh, okay, I'm going to translate you in to that private IP address because that's the mapping I have. What if there's a 1 in 65,000 chance that this computer right here happens to get the same port number that you generate when it opens Firefox or Chrome or Internet Explorer? Right? It gets 6711. Well, no worries. Whoever goes there first will get the 6711 just like you're seeing there. The second guy to make it to the router will actually have it become, it'll say the inside address will be 6711, and then the outside it will translate to 6712, or the next available free one that's in there, and the table will keep that unique for any of the replies that come from the outside world. Before I show you what can go wrong with NAT, let me give you a flyby configuration just to refresh you, right? I set up a simple GNS3 topology here where I've got this guy on the 170.1.52.0 subnet. He's .100, and I actually did no default gateway on this guy. So essentially the only way he's going to be able to communicate to that PC is if he thinks that PC is actually coming from this IP address, right? Because it's on the same subnet as him. So this guy needs to be able to ping through, get NATed on this router to this IP address right there, so that this guy is able to respond back thinking he's talking locally, because if it's anything that requires him to have a gateway, he doesn't, so we'd be stuck, right? So I'm going to go on router 1. Here we go. And let's go into global config mode. Let me just do a quick show IP interface brief. We've got IP addresses listed right there. Show run interface fast Ethernet 0/0 and 0/1. Just again, want to get familiar with the configuration that's there. Okay, first things first, always go into the interface and do inside and outside. IP NAT inside and IP NAT outside on the outside interface, right? Label those directly. Now, we need to tell it what addresses are allowed to be translated. I like using named access lists for this because I can quickly look at the name and remember what it is. So I'll say IP access list, let's do an extended access list, and we'll say NAT addresses. Nice thing about using extended is if I need to exclude certain things, like I don't want it to NAT when certain things happen, I can do that by saying, you know, if this source to this destination is denied from being NATed, by putting in here. Very handy if you want to do something like VPN connections from your router. So I'm going to do IP, what am I doing? I'm in the access list. Okay. Permit IP from the source of 10.2.2.0 wildcard mask. There we go. And I will say to, let's just go wild. Any destination that permit IP, what am I thinking? Any destination. Oh, for some reason that's it. My brain is like NAT command overload interface. Anyway, so I'm learning. By the way, yesterday was my birthday. Happy birthday to me. But as I get older, I find, you know, I'm normally really scattered, but now I'm really scattered. So I'm going to do IP NAT. Here's the command that glues it all together, right? IP NAT inside, because I'm translating from the inside out, inside being defined by those IP NAT inside outside commands. So say the source address I want to translate is coming from the access list. And we will do, what did I name it? NAT underscore addresses. And I'm going to go to the interface. I could define a pool of addresses if I wanted to, if I had an outside pool. But I'm going to say just go out the interface, and it was fast Ethernet 0/0. Fast 0/0. And then you don't want to forget this overload keyword. Otherwise, you only get one translation, and it burns the interface IP address, and no one else will be able to get out. Overload is what instructs it to use PAT, right? Okay, good. So let's see. Let's test it. I'm going to go to PC2 down there. Bring him up into the picture. Please. Where is PC? Did I already have it open? PC2. Okay. I already had him open. Okay. So PC2, let's do a quick show IP. He's got the IP address 10.2.2.50. Man, I got to get better at placing these things. 10.2.2.50 down at the bottom, and he's going to 10.2.2.1 as his gateway. Let's just ping 10.2.2.1, make sure that's working good. And let's just go hog wild. I'm going to ping 170.1.52.100. This is how Cisco techs go hog wild. So I'm getting replies back. Let's make sure that it truly is natting and not routing. So I'm going to go over to router 1 in this case, who has NAT set up, and do a show IP NAT translations. And we should see cha-ching using the ICMP translations, one for each and every ping, because ICMP is stateless, meaning it's not creating a TCP session that translates all the traffic through it. So every single one of those ping messages has its own unique port number, shows where it's coming from, where it's going to. That's a quick and dirty configuration of NAT. So what could possibly go wrong with that? Seems so simple, right? Well, first off, not identifying the interfaces correctly. Going in and doing the IPNAT inside and outside on the right interfaces as well. Don't forget about this. If you've got the sub interfaces, like you're pulling off a router on a stick, you have like fast Ethernet 0/0.101. You need to squeeze that IPNAT inside command underneath those as well, just like you do on the physical interface going in and out of the device, right? So you got to do that. Second thing is the NAT pool could be misconfigured. Now, I went in and I used the interface right here as the NAT overload, but you could very well go in and set up a pool of addresses. It looks something like this, where I could go in and do IPNAT pool, and I could say the pool will be named cool pool, right? And then I can do the start and end address. So we'll say it comes from 200.1.1.1 to 200.1.1.52, right? I got to put the mask on there. So net mask and right. So that's where I can have 52 addresses in the pool being used. Why would I do that? Well, once you max one of them out, meaning you've used all of the port numbers that are available, which happens on our busy internet savvy networks of today, it can actually fail over and start using the next and the next and kind of filling up each one of those as the port numbers saturate. Well, if you do that, you need to change your IPNAT inside command to say IPNAT inside source address. You would do the list of blah. And then you would say I'm going to go to the pool of addresses, and I would put cool pool as the address list to be used, plus want to put overload on there. Otherwise, you're only going to get 52 individual IP addresses that get out, and then you max out because it does one-to-one translations if you don't put the overload on there. So all that being said, if you misconfigure that pool, put the wrong addresses or addresses that you don't have or own, then it's not going to work. Access list does not identify the correct IP addresses. I thought it that's it. I had something brilliant to say for that, but it just left me. Missing the overload for PAT, I've mentioned that a couple of times. Here's the commands that you can use to verify this. Let's just jump on our router and see what each one of those looks like. I can do a show run include IPNAT, and that will show us every NAT command in the configuration. Now I do need to know which one of the interfaces those go under, so that's a lot of times where you can do a show run section interface and just get a report of all the different interfaces and what NAT commands go underneath. You could get fancy. You could come up with a crazy cool macro on this thing that filters just the interface, and I kind of want to get crazy. Show. I don't know why I get these. So I'm going to say include interface and let's do IPNAT. Crazy. All right, so I can do, I showed you this one, show IPNAT translations, right? Probably blanked out by now because they've timed out. They do only live for a certain amount of time. I can do a clear IPNAT translations, where that will allow us to wipe out that table if there's something in there, or I can do one individual entry that gets stuck. I had to do this when we do changes of IP addresses and things like that to wipe it out and get a fresh set of translations. Show IP NAT statistics. That's an interesting one. Show IP NAT statistics will show how many hits and misses you've actually had. Hits and misses do not mean like I translated and I didn't translate. Essentially, a miss means there was not a NAT translation already in the table, and it had to create one for it, right? So you're able to get a quick gauge of that going through. And of course, debug will actually show the NAT as it's happening. You are now a NAT troubleshooting ninja. I hope this has been informative for you, and I'd like to thank you for viewing.